In this video, we'll be learning how to differentiate constants. Now, let's say we're given a function, f of x, which is equal to some number, k. In other words, there's no x on the right-hand side there. Then the rule is, to differentiate this function, f dash of x, this will always be equal to 0. So let's see how this rule works. Let's say, for example, we're given f of x equals to 3. Then in this case, the derivative, f dash of x, using the rule we just learned, will simply be equal to 0. In a similar way, if we were given another function, let's say it's g of x, and that is equal to -5, then using this rule again, the derivative, g dash of x, will just be equal to 0 again. In other words, as soon as we have a constant, just a number, its derivative is always going to be equal to 0. Let's try and see why this is. Let's say we consider the curve, or I should say the line, y is equal to 4. Then if we were to draw this on an xy grid, x and y, then as you probably know, this would be a horizontal line. That would be our line y is equal to 4. And now the key thing to remember here is that when we're looking for the derivative of a function, what that derivative tells us is the slope of the function at any value of x. But now looking at this line, we can see that the slope, or another word for that of course is gradient, we can see that the gradient is always 0 because the line is horizontal. But since the gradient is 0, that means that the derivative, f dash of x, is also going to be equal to 0. And that explains why we have this rule. If f of x is equal to just some number k without any x's there, then the derivative, f dash of x, is always going to be equal to 0. And there you go. You've just learned how to differentiate constants.